Good morning, students. Welcome to 10th Science. Unit 10, Types of Chemical Reactions, Part 2. Now, let us recall what we learnt in the previous class. Introduction, Types of Chemical Reactions. The first one, combination reactions. Second one, decomposition reaction. It is classified into thermal decomposition reactions, electrolytic decomposition reactions. Third one, photochemical decomposition reactions. Now, what are the differences between combination and decomposition reactions? First one, combination reactions. One or more reactant combine to form a single product. Hydrogen combines with chlorine to form hydrogen chloride. Then decomposition reactions, a single reactant is decomposed to form one or more products. Calcium carbonate, if it is decomposed to form calcium oxide and carbon dioxide. Second point, the energy is released. Here the energy is absorbed. Third point, elements or compounds may be the reactants. Here a single compound is the reactant. The third type is single displacement reaction. It is a reaction in between an element and a compound. For example, what does single displacement reaction means? The reaction in which a more reactive element displaces a less reactive element from its compound, it is called as single displacement reaction. Here the element and compounds, they react. One of the element of the compound reactant is replaced by the element reactant to form a new compound and an element. The general schematic representation of a single displacement reaction is given below. Element A plus compound B and C. It gives a compound A and C and an element that is B. For example, a zinc metal, it reacts with hydrochloric acid to form zinc chloride with the liberation of a hydrogen gas. In this reaction, a zinc metal is more reactive than hydrogen. The second equation, iron, when Fe, it combines with copper sulfate to form ferrous sulfate and copper. Here, which is more reactive? Iron is Fe is more reactive than copper. If iron nail is placed in an aqueous solution of copper 2 sulfate. Come to see the picture. What is the color of copper sulfate? If it is blue in color. If you place an iron nail, it changes into green in color because of the formation of a ferrous sulfate. Here the copper is deposited on the iron nail. Here the iron displaces copper from its aqueous solution and so formed copper deposits over the iron nail. Here the copper sulfate, blue color of the copper sulfate changes into green color of the ferrous sulfate, FeSO4. One more example, that is reaction with halogens, sodium, chlorine, bromine, iodine. So these are called halogens. NaCl, it reacts with fluorine, F2 gives NaF plus chlorine. Here, which is more reactive? The fluorine is more reactive than chlorine. So a product is sodium fluoride and chlorine gas. The second reaction, that is NaF, sodium fluoride, it reacts with chlorine and it forms sodium chloride and fluorine, but it is not possible because here the fluorine is more reactive than chlorine. The first reaction involves the displacement of chlorine from NaCl by fluorine. The second reaction, chlorine displaces fluorine from NaF. Out of these two, the second reaction will not occur because fluorine is more active than chlorine because it occupies in the upper position in the periodic table. So, in the single displacement reaction, more active element readily displaces the less active elements from their aqueous solution. Now come to the fourth type, double displacement reactions. What does double displacement reaction means? When the two compounds react, if their ions are interchanged, then the reaction is called double displacement reaction. Ions means plus, the same ion plus the cation can be replaced by cation. So, the ion of one compound is replaced by the ion of the another compounds. Ions of identical charges are only interchanged. That is, a cation can be replaced by other cation. So, this reaction is called metathesis reaction. So, what does double displacement reaction means? When two compounds react, if their ions are interchanged, that is called as a double displacement reaction. Now, the schematic representation of a double displacement reaction. A and B, it's a compound. It reacts with another compound C and D. Here, their ions are interchanged to form a new compound AD plus CB. So, for a double displacement reaction to take place, one of the product must be a precipitate or water. By this way, there are major classes of double displacement reactions. They are, first one, precipitation reactions. Second one, neutralization reactions. Now come to the first one, precipitation reactions. When an aqueous solution of two compounds are mixed, if they react to form an insoluble compound and a soluble compound, then it is called precipitation reaction. For example, lead nitrate PbNO3 twice. It mixed with potassium iodide Ki. It gives a precipitate of lead iodide PbI2 and plus potassium nitrate KNO3. This lead nitrate is a yellow color of lead iodide is formed. Here the potassium and lead, they replace their places. So, potassium and lead displace one another and form a yellow precipitate of lead 2 iodide as shown in the figure. You can see the picture. A yellow precipitate of lead iodide, that is PbI2, is formed. The second type is neutralization reaction. In this reaction, the acid reacts with the base to form salt and water. It is called neutralization reaction, as both acid and base, they neutralize each other. So, acid, it reacts with base to form salt and water. For example, sodium hydroxide, NaOH, it is a base. It reacts with an acid, HCl, to form NaCl. NaCl is a salt, sodium chloride, to form and water. Here H2O. The second example, nitric acid, it is an acid, HNO3. It reacts with a base, ammonium hydroxide, NH4OH. Acid and base, they react to form salt, ammonium nitrate, NH4NO3, ammonium nitrate and water. So, acid, it reacts with the base to form salt and water, and this reaction is called as a neutralization reactions. The fifth one, combustion reactions. Combustion means addition of oxygen. A combustion reaction is one in which the reactant rapidly combines with oxygen to form one or more oxides, and it produces the energy as heat. So the heat is liberated, so it is called as an exothermic reaction. So in combustion reaction, one of the reactant must be the oxygen. For example, LPG gas. LPG gas is a mixture of hydrocarbon gases like propane, butane, propylene, etc. All these hydrocarbons burns with oxygen to form carbon dioxide and water. For example, propane C3H8, it combines with oxygen O2 to form carbon dioxide and water. It produces heat. So the heat is liberated. It is called as an exothermic reaction. Here the addition of oxygen, so it is called as an oxidation reaction. Now balance the equation. Here 8 hydrogen. So here I put 4. So 4 2s are 8 hydrogen. Here C3. So here I put C. So 3C. Now check the oxygen. 3 2s are 6. 6 plus 4 oxygen. So totally 10. So here I put 5. 5 2s are 10. So the reaction is a balanced chemical equation. The next one, classification based on the direction of the reaction. Now, there are innumerable changes occur every day around us. We know that, for example, a liquid, it freezes into ice, and then the ice melts into water. It is a physical change because it is a not permanent change. So, it is called as a physical change. So, the physical changes can be reversed easily. But now, come to the picture, burning of wood. Burning of wood. Here, the wood contains a carbon compounds present in them. So, this carbon compounds combines with oxygen to form carbon dioxide, water with the liberation of a heat. Here the gas is produced, the gas thus escapes out. It cannot be reversed, so it is called as a chemical reaction. So the chemical reactions cannot be reversed. Most of the chemical reactions cannot be reversed, but some of the chemical reactions can be reversed. Some of the chemical reactions can be reversed. For example, our mobile phone gets energy from its lithium ion Li plus battery by chemical reactions. It is called as discharging. Again, on recharging, the mobile phone chemical reaction takes place. It is a reverse process. So thus the chemical reactions may be reversed under suitable conditions. So based upon this classification, it is classified into two types. The first one, reversible reactions. A reversible reaction is a reaction that can be reversed. A reversible reaction can be represented by the following equation. AB is a compound. A compound AB, it decomposes to form A and B. It is called as a forward reaction. And A and B, it combine together to form a compound AB. It is a combination reaction. So the decomposition reaction is called as a forward reaction, and the combination reaction is called as a backward reaction. So here a compound AB undergoes decomposition to form the products A and B. It is the forward reaction. And the products are formed, they combine together to form a backward reaction, that is AB. So the reaction takes place in both the directions. For example, consider the following decomposition reaction of phosphorus pentachloride PCl5. It decomposes PCl5 phosphorus pentachloride. it decomposes into phosphorus trichloride and chlorine. It is a forward reaction. And the phosphorus trichloride and chlorine, it combines together to form PCl5, phosphorus pentachloride. It is called as a backward reaction. It is a combination reaction. Another one more example, the hydrogen peroxide, H2O2. If the hydrogen peroxide is poured on a wound, it decomposes into water and oxygen, H2O and O2. And the gaseous oxygen bubbles away and it is formed, thus prevent the formation of H2O2. Here the hydrogen peroxide, it decomposes to form water and oxygen, H2O and O2. And H2O and O2, they combine to form H2O2. This is hydrogen peroxide. Now balance the equation. Here totally 2 plus 1 oxygen. So here I put 2. So totally here 4 oxygen. So here I put 2. So 2 2s are 4 oxygen and 2 2s are 4 hydrogen. And so this reaction is a balanced chemical equation. The second type is irreversible reactions. The reaction that cannot be reversed is called irreversible reaction. For example, consider the combustion of coal into carbon dioxide and heat. For example, coal, see, it combines with oxygen to form carbon dioxide and it produces heat. Heat is liberated, so it's an exothermic reaction. And here not water, in the book it is not wrongly printed, it changes this into heat. So carbon, a coal combines with oxygen to form carbon dioxide and it produces heat. So this is the reaction of, in this reaction, a solid coal burns with oxygen, gets converted into carbon dioxide gas and heat. What are the differences between reversible and irreversible reactions? The first one, it can be reversed under suitable conditions. Here, irreversible reaction cannot be reversed. Second point, both forward and backward reactions takes place simultaneously. Here it is unidirectional, it proceeds only in forward direction. It attains equilibrium. Here equilibrium is not attained. Here in reversible reaction, the reactant cannot be converted completely into product. For example, PCl5, it gives PCl3 and Cl2. So again it combined to form a reactant. Here in irreversible reaction, the reactant can be completely converted into products. Coal, it combines with oxygen to form carbon dioxide and produces heat. The last point, it is relatively slow. Here the irreversible reactions are very fast reactions. Yes. Now come to the assignment. First one, explain the types of double displacement reactions with examples. Second one, what is combustion reaction? Give example. Third one, write the differences between reversible and irreversible reactions. These three questions you have to learn and write one time. Okay students, thank you.